Yes.
There we go. So a benchmark is a known elevation. In this particular diagram, an MH is classified as a manhole. Oh, spelled that wrong. Is a manhole. S on this drawing is the sewer. NTS on this drawing means not to scale. The north arrow like that means north. Okay, so I want to make a couple of notes again on this particular picture. So down here in the bottom, let me just slide this up a little bit. This is the benchmark to the manhole. This is the manhole. These numbers right here, the 636,740 are inverts. This is an invert, this is an invert, this is an invert. These elevations right here are exactly that. This is just straight elevations. These are dimensions, and these dimensions are in millimeters. Millimeters, millimeters, millimeters. Okay. This right here tells you the size of the pipe at what grade it's running. So right here, it's the size of pipe. That's 250 millimeters or 10 inches. And this is the grade that it's running. This is another elevation, the 642,220, and this is an architectural elevation. So this is a geodetic elevation, and this is an architectural elevation, 100 meters. This S right here indicates the sewer. Okay, so now I'm going to outline the property. Okay, so here is the property line for this particular application. You can see how it angles off there. This is the property line for this house right there. Okay, that's the property line for that house. These corners are just given elevations of the property. Those are given elevations. This is a measurement of this little corner here. It looks like that, sort of. Okay, so on the next picture, we need to maybe know a little bit more information. Let me just pull back again. Also, this up here means not to scale. This is the top of subfloor right here. And they have an architectural elevation of 100 meters. These measurements are in millimeters. They're all in millimeters, all of those measurements. This is the concrete slab. This is the footing. This is the joists. This is the ground level. This is the ground right here. This is ground, right? So this is underground. All of this is underground in here. This is our building sewer. That's running at a grade of 2.08%, and it's a 100, there's the 100 millimeter, which is 4 inches. Okay. Is that clear? Any questions on that? Okay, so having said that,
where'd you get the 100 when you did the top subfloor there?
it's a given right
It's a
here.
given?
See right here,
Okay.
other page. There it
Yeah.
is.
All right, perfect.
So the finished floor 642,220. So finished floor is also 642,6, whatever that number was. Can't remember. Okay, so with some notes, I'm going to actually, this is the detail of the manhole. As you can see, pipe is coming in and pipe is going out. In manholes, you could have other pipe running in and putting their effluent in. So you could have more than one pipe dumping in sewage or storm or whatever it is into these manholes at any point. So you can do that. Okay, and that's what they do in this picture. We have 3 over here. In this corner, we have 3 pipe going into one manhole. Yeah, manhole number 22. We have 3 separate pipes going in there. The red outline here on this picture indicates the house or the building that that's on. And as you can see, the red here on this picture shows the top of subfloor or finished floor, and this shows the earth where that is. Over here, I have my extra note on what a invert is. The invert of a pipe refers to the lowest point of the inside of the pipe. The invert level is the vertical distance from, or the vertical distance of the invert above some fixed level or datum. So right there, these numbers are inverts. These 3 numbers on the manhole are inverts. Okay, that's what those are. So now I need to pause. So get your calculators, get your pencils. We're going to go through this next assignment. We're going to do all of the questions on here, but I need to take a quick break and I will come back here, take 20 minutes, come back at 9 o'clock and we'll continue on.
Sorry, Doug, just one question. Is there a simple term you can use for invert level, distance from invert to fucking?
Well, a known elevation.
Okay.
Okay, there's going to be a known elevation to that. So I need to take a break. I'll be right back. 9 o'clock. All right, so we're gonna go to start at 5A, and I believe 5A says, what is the actual elevation at the northwest corner of the lot? Okay, so when it says actual elevation, they want geodetic. They want the geodetic number there. So if I go to the northwest corner of the lot, what is your answer? 641,370 millimeters. There it is right there. You see that? Everybody got that answer? So this particular assignment builds upon some of the other answers you get in previous questions. So it needs to be in chronological order when we go through this, okay? Needs to be in the right order. You need to do each one in order. So in this particular question, what is used for B? What is used as the benchmark? Shout it out if you know.
640580.
Manhole 22.
It's manhole number 22 is the answer. So manhole number 22 is used as the benchmark. Now, again, the benchmark is the actual elevation of the benchmark, which is C, the next question, which is 640580. There's the actual. Okay. So some of these questions you really got to narrow down to what actually they're asking for. So we are on question A, B, C, D. I think question D is asking what is the area of the house in meters squared? I want you to take a minute and see if you could come up with that answer. So area of a square is length times width is equal to the area. And we want it in square meters. So really, it's going to be 7.8 meters times 12 meters. Yes. Everybody get 93.6 meters squared as the area of the house. All right, we got that. That's excellent. Let's look at the next question here. The next question says, what is the actual elevation of the main floor? Right here, 642, and I should not be using this color. 642,220 is the actual or geodetic elevation of the main floor. Next question says, what is the architectural elevation of the main floor? And we determined that before. It is 100 meters right there. The next question on here, what is the distance between, oh, David, isn't that nice? What is the distance between the sewer main and the house? Okay, so this picture right in here, here's the sewer main right here. This is the sewer main. So I want to know from the house to the sewer main, what is that distance there?
15,000 millimeters.
That's right. 15 meters is what David said. Okay, so far so good, eh? So far this is pretty darn easy.
What's that 100 though? Below
The
that?
100 is an architectural elevation of the main floor. That is numbers, that's A, B, C, D, E, F, I think F. Okay. Does that answer your question? Yeah. Okay, let's go to the next one. What is the architectural elevation at the top of the basement slab? So we have to go to this picture next. Now, the architectural elevation here is 100 meters right here at the top of the finished floor. Yes. I want to know this elevation right here at the top of the basement floor or the basement slab. So we're going to take 100 meters and we're going to minus off 2.85 meters, right? We're going to minus off this number right here, 2.85 meters, giving us 97.15 meters is right here. 97.15 meters is the architectural elevation of the top of the basement slab. The next question says, what is the architectural elevation of the benchmark? So I'm going to go back to my other sheet. So here we have the benchmark down at the bottom, 640,580. And we have a geodelic elevation of the finished floor. So what we do is 642,220. That's this one right here. And if we minus off the benchmark here, 640,580, we will get the architectural elevation of the benchmark, which would be 1.64, isn't it? But that's the actual drop. That's not the answer. That's how much it drops, right? So we have 100 meters minus off 1.64 meters. The architectural elevation of the benchmark is going to be 98.36 meters. From here all the way to the benchmark, that drops 1.64 meters. Okay. Now we're getting into some stuff now. The next question says, what is the actual invert of the building drain, where the drain leaves the house? Okay, so we know, let me just go over here and I'm going to erase this stuff so we could start a fresh page. So we know the geodelic elevation of the slab or the top of the finished floor is 642. Or I shouldn't put a decimal there. 220, right? I know that to be true. So I want to know the invert elevation, and invert is the bottom of the inside of the pipe. So we're going to minus off this. We're going to minus, okay, 642,220. We're going to minus off this 2850. We're going to minus off this 100. We're going to minus off this 200, right? We're going to minus off this 200. And then we're going to minus off 100 for the diameter of the pipe as well. And then I come out to the actual invert elevation where the drain leaves the house. If I do my math right, 63877, or excuse me, 770.
So these are always in meters then, right?
Listen, these are millimeters. All
Okay.
of these numbers are millimeters. It's all millimeters.
And that's the geodetic, right?
That's geodetic. So that's the actual invert elevation. So anytime they say actual elevation, you're going to go geodetic.
Okay.
Okay. So that's the actual invert elevation of our building drain.
You're taking off that extra 100 mil just because that's going to be the bottom of your pipe, correct?
That's correct. So that's why that extra 100 is taken off there. That is correct. Okay. The next question is, what is the actual invert elevation of the sewer main at the east side of the manhole? So let's have a look. What is the east side here? So this north is straight up. That's north. So that's got to be east. That's got to be west. This has got to be south, yes? So for this question, here is your answer. 636,740 is the actual invert elevation of the sewer main at the east side of the manhole. So can anybody tell me, just shout it out if you can, which way this sewer runs? This one.
West.
It runs this way to the west, yes? You can tell by where this is. That's right, Jarrett, correct. You could tell by that 45 and Y in there because that's the way it would run. Okay. You could also tell by the elevation of some of these. So sometimes you can tell by the elevation if there's just one in and out, whatever one is higher, it's flowing that way, if you can determine that. There's just one in the manhole. All right. Which corner of the property is the highest? Anybody know what corner is the highest out of this property?
Northeast.
Northeast. So this corner right here is the highest
Yes.
of all of them? Yes. Yes, it is. So that's going to be the northeast corner is the highest on the property. Okay, the next question is, what is the architectural invert elevation of the building drain under the fitting, under the footing, excuse me. So let's go back here. Now, we want to know architectural. Remember, we start at 100 at the top of the finished floor. And we're going to go all the way down. So we're going to start at 100 and we're going to minus off 2.85. We're going to minus off 0.1. We're going to minus off 0.2. We're going to minus off 0.2. And we're going to minus off 100 or 0.1 again for our pipe. And you should have the architectural invert elevation of the building drain out of the footing at 96.55.
Hey Doug, why is it 100 or 100 for the pipe?
Because it says right here it is a 100 building sewer. And that is the size, 100 millimeter pipe. And remember, invert is the bottom of that pipe, the bottom of the inside of the pipe. Does that answer your question?
Yeah, thanks.
So Doug, your architectural is always in meters and your geodetics always in millimeters, correct?
Pretty much.
Okay.
Yeah. So again, why in the hell, as plumbers and gas fitters, are we talking about invert elevations? Well, listen, we as plumbers and gas fitters take our backhoe or take our shovels, right? Here's your shovel. And you got to dig to this pipe. Sometimes you have to dig, so you have to know where this is and where it goes. So you will be given invert elevations on a print, and the city of Calgary will say you need to be at this invert with your drainage pipe. So you better be there. You better not be too low because that's going to be a problem. So this is where it comes in, that we need to know what an invert is and how to attain it. And this is what we're doing today. And I can't get rid of that. There we go. Sometimes when this draws circles on there, I can't get rid of everything here. Hang on. That's just ridiculous. Okay, the next question. What is the architectural, what is the actual invert elevation of the sewer main where the building sewer connects to it? Okay, so we're going to go back to this picture. Okay, so the question again says, what is the actual invert elevation of the sewer main where the building sewer connects to it? So where's our building sewer here? Right here is where our building sewer. And we want the actual invert elevation of the sewer main. So we want this elevation here. I think that's what they're asking for. So we need to know the distance this runs, right? We need to know the distance of our run. So anybody figure out the distance of our run here? That's 9,000 plus 6,000 is how much, Brad?
15 meters.
15 meters is our run. Yes, of our building sewer. But because we actually have an invert here, that's our building sewer. You see what we have an invert right here. Do you see that? The 636740. So what we'll do, hang on a second, let me just zoom in. So the 636740 is what we have, right? 636740 is this invert. So what we're going to do is we're actually going to go right here. Because this is an actual invert, we can then determine this run. Let's determine how far this run is at this grade. And we'll just add it to this number. And we should be able to get what we need. So how much is this distance right here? Well, we might have to go to here. So take a minute and find out this distance. Where'd you get the 6 from? Oh, I see. You got it from here, but let's go to the pipe. Let's go to the pipe right here. Okay, let's go to this pipe.
You have to add that 3,394 too.
3,000. And then if we go to there, but we got to minus off this much and this much as well. So 3,000, let me just add this up, 3,000 millimeters plus 12,600 millimeters. That's 15,600 millimeters, or 600, not 6,000, Doug. Okay. Oop.
But now isn't there a gap between that 3,000 and 12,600?
I don't see a gap in there, but
For the 45s, the point only goes to that certain distance.
yeah, let's go just to the straight pipe though. We'll get this distance. Now that comes up to here, but we only need to here. So we have to take off. How much is this? Right up here, 1,500. And how much is this? 1,500. So we must minus off that. Let's see, 12,600. I shouldn't actually go that far, should I?
Do you have to do anything with this number here? Oh, you zoomed out.
Yeah, it's okay. You can zoom out. Woo. Okay, let me just go up here. Look at this number, 1,500 to right there. So let me just put in a different color. So up here, you see 15,000? That is to that line right there.
That's the moneymaker.
Okay, so we have 3,000 and 15,000. So let's take this off. We have 3,000 and 15,000 to make 18,000. And then I have to minus off this, which is minus 15. And I have to minus off this, which is 15, which is 3,000. So it runs 15 meters. This is this line, 15 meters. So this minus this and this gives me 15 meters. Because that's added and then we have to take it off. So my run is 15 meters. Man, my computer is just wonky today. So I running at a grade of 50.52%. So my run is 15 meters. and my grade is 0.52%. So 0.52 divided by 100. So I multiply by 0.0052. And that equals 0.078 meters. Is the amount of rise. So I can convert that to millimeters, which is equal to 78 millimeters. So my benchmark or my invert is 636,740, and I simply add 78 millimeters to that to get me 636,818 millimeters is the invert elevation here. A lot of work for one question. And this is why we're going through it. So we know what we got going on. Okay, take that off. Okay, next question. That was for P, I think, yes. All right, now the next question says, what is the architectural elevation of the southeast corner of the lot? So southeast corner, and I want architectural. So we have the 642,220. Where's southeast corner of the lot? There's the southeast corner. Yes. So let's find out how much that drops. 642,220 minus 641,330. How much does that drop?
Where's that 642,220?
1, 2, 3. Yeah, 642,220. Right up
Oh,
here.
Jesus, never mind.
Okay, no, that's okay. Keep watching because that's important. Because I can make mistakes quite easily. Is that 890 correct? 641,330. Yeah, 890. So now this is millimeters, right? So I want the architectural elevation. So we start at 100 meters and we're going to minus off 0.89 meters because that's what that is in millimeters. So for this one, it says our architectural elevation at the southeast corner is equal to 99.11 meters. Okay, next question. What is the area of the lot in square meters? Now, this is the lot we're talking about. So if I was to Where is the lot?
7,800 and 12,000, right?
I don't think so.
It should be the 15 at the top, the
So
33,
it's
6.
15 meters by
Oh, the entire lot, I see.
33.6 meters.
And then we gotta take out that triangle.
Then
I
we
just
have
pointed
to
out.
take out this triangle down here. That is correct. So this triangle, it down here at the bottom says that it is 24 by 24, 2.4 by 2.4. Area of a triangle is base times height divided by 2. So that's going to be 2.4 times 2.4 divided by 2 is equal to the area of this little corner here, right here, this little corner has an area of 2.88 meters squared. So the lot without that square is 504 meters squared, and I have to minus off this triangle, 2.88 meters squared, minus that off to get me 501.12 meters is the area in square meters of the lot. Everybody good?
Mind just going through that just once more?
Sure thing. Okay, so the area of the lot, so it's 1,500 at the top, right? 15 meters by 33.6 meters. Yes? Which comes out to 504 meters squared if I times those together. But down here in the corner, you can see that I have this little triangle there. So this is 2.4. This triangle is 2.4 by 2.4. So to find the area of a triangle, it's base times height divided by 2. So 2.4 times 2.4 divided by 2 is equal to 2.88 meters squared. And I minus off that to get me a total area of 501.12 meters squared.
Isn't the base the 3394?
No, the 3394 is the travel.
Okay.
So it's 2,400 times 1.414 is the travel. Okay, good. Got that? All right, excellent. Okay. All right. Now. Let me go back here. Next question. What is the architectural elevation at the bottom of the footing? I don't know what you mean by that, Brad. You want to clarify? Oh, you mean while you're doing this math, you would be done the house? Roughed in? Okay, so the next question is, what is the architectural elevation at the bottom of the footing? So we're gonna go back here. Now, architectural elevation, as you know, we start at the top of the main floor, which is 100 meters. So we want to know the bottom of the footing. So right here is where we're going. So we take 100 meters and we minus off 2.85 meters. And then we minus off 100, or excuse me, 0.1 meter. And then we minus off 0.2 meters. And then that's it. That should be it. So it should come out to what? 96.85 meters is the bottom of the footing. Okay. Now, the next question, what is the architectural invert elevation of the building sewer at the property line? So before I can carry on, look at what our grade is. Right here, our grade is 2.08% on our building drain or building sewer. Okay. So we want to know the invert elevation of where we connect to this main sewer. So we got to know how far our building sewer runs. So we start here and we end here.
Hey Doug, it says the property line, so wouldn't it technically be higher up there?
Oh, does it say the property line? Sorry. That's right. It's right here. Excuse me. Yes. Not at the sewer, right there. Thank you for that. So we are going to the property line right there. So this is where you would have to excavate and put your pipe in at that invert. And then the city will come by and hook you up. So you're going to have to dig that deep. So how deep is that going to be? And we want to know the architectural invert elevation of the building sewer at the property line. So we know in the previous question, or some of the previous questions, what is the architectural invert elevation of the building drain under the footing? I believe we came up with 96.55 meters for that. And that's way back at another question. Now we're going to run this pipe this long at this grade. So this is 9 meters, right? So 9 meters is my run. And I'm going to times that by my grade, 0.0208. Times 9. So I have a drop of 0.1872 meters. Now I will minus that off of my already known invert elevation of my build-a-drain under the footing. And it'll get me my invert elevation at the property line. And that should equal 96.3628 is my invert right there. Pretty good, eh? Pretty good so far?
What was
Got-
that last step, sorry?
I got 0.85.
Can you do that one again, please?
Sure, we'll do that one more. So previously, let me just go back here for a second. Previously, we got our invert elevation right here. We did this in a previous question, right? And we got this at 96.55 meters. That was the architectural invert of my building drain underneath my footing. Okay, we already got that. So we're going to use that information because we're going to run from here to the property line. So we have a run of 9 meters or 9,000 millimeters. And we're running at a grade of, and if I go back to the other page, the grade was 2.08%. So I'm going to take my run, times it by my grade, 0.0208. Which gives me a drop of 0.1872 meters. So this line, my building sewer drops down 0.1872 meters from my house to here. And now I will take my known invert from the house where that pipe is, and I'll drop it down 1872. And I'll minus that off of my 96.55 because we're going deeper. We have to minus it, right? .1872. And that comes out to 96.36 meters is the invert elevation at that point.
Quick question for you, Doug.
Yes, Brad.
So let's say when you click before you dig, for example, are you ever able to follow services along that? Like, let's say you had a pre-existing gas line that was going to a shed or a garage or something, and you wanted to run like a sink drain. Would you be able not to follow next to it, not dig it up and then obviously follow next to it, but wouldn't you be able to kind of follow that run, sort of that direction, if you wanted to tie in towards the house or something?
That's a good question. Listen, this is going from your house to the property line, so you're not running anything.
Right. Okay.
There. Electrical and gas are buried at different depths. Building
Frost line and stuff.
7, at least below frost level, 6-7 feet.
Okay. Just curious. Thank you.
Sure. Okay, the next question is, what is the difference in elevation between the finished floor of the house and the top of the manhole? So the manhole elevation is 640,580. The finished floor elevation is 642,220. So we minus those two off. So 642,220 minus 640,580 minus 640,580 is a difference of 1640. So what we do is we take the difference, and I could just say it is 1640. That's the difference in elevation, 1.64 meters or 1,640 mils. That's the difference. That's it. The next question. It says, how far is the connection for the building sewer from the manhole? I think we've already determined this. So the building sewer to the manhole, I think we've already determined this before, did we not? Isn't it 15 meters? Did we already determined that?
We did sewer mains in a manhole.
Yeah, same diff. This is our building sewer. This is the building sewer. And this is the manhole. So yeah, 15 meters. We already did that. Yeah. So that was easy. The next question is, what is the total drop of the building sewer from the house to the main sewer? So from the house to the main sewer, what is my total drop in distance of my pipe from there to there? So I know that I'm running at 2.08%. I have a distance here of 15 meters. So I take my run and times it by my grade. Fifteen times 0.0208. Or 312 millimeters, either or. Remember, the 2.08 is actually equal to 0.0208 when we multiply, because it's a percentage. Remember, we always have to divide that by 100. Next question on the list says, what is the difference in invert elevations between the main sewer and the building sewer where they connect? So I can go back and do something different, but what we'll do is we need the invert elevations between the main sewer. So this is the main sewer right here. Oh, where's my pen? This is the main sewer right here. And the building sewer right here. So we need to get this elevation here and this elevation here. So we have to do two separate calculations on this. So we need to know first the invert here. I think we know the invert right here. Didn't we get that on a previous question? There it is, 96.55. But let's take off 6.55. So that's 3.5 meter drop. So this is 6422202. And if I take off whatever that drop was, that was 3.45 meters. So let me just do that math. 6.422220 minus 3.450. So this invert now becomes geodetic at 638770. Okay, that's this invert there. Now I have to minus off the 15 meters, that total drop. I think we had it from our last question. We took our total drop of this run to be 312 millimeters. Isn't that right? Somewhere around there. So I have to minus off that drop of 312 millimeters off of that. So that gets me right here for the building sewer of 638458 is my invert of my building sewer. Now the main, like they're not going to be at the same elevations because one is a 10-inch pipe. So this is a 10-inch pipe here and one is a 4-inch pipe. So if I had to look at that, it's going to be tied in kind of like this. And then this is my building sewer and this is my main sewer. It's going to be at different elevations. At that is this point right here. That's what that would look like. So let me just get that invert from here. So I have 636740 and I'm rising up, right? Or did we already find out what this invert here is? I think we found out what that invert was on a different.
Yeah, we did. I think it.
What was this invert? Well, listen, we can still do it again. I have to multiply by my run. So that's going to be 0.052%. So 636740 times, ooh, I added. Times that by my 0.052. Whoa. That should be an extra 0 in there. Thank you. 636740 times 0.0052 gives me a rise of 3311. We'll add that to the 636740. One moment, please. Okay, guys, see if you could find that invert there or the difference in invert. Work on that for a second. Sorry about that. Had to talk to Marty for a second. He talked to me. Yes, that is correct. Dustin, you are right in the chat. So let me just finish that off. Where are we here? So the 636,740 plus 3311 equal, I don't know what that is. Oh. $818. Where'd you get the 818 from? 636, 818, and then that comes out to 1640. That is correct. Well, that doesn't work out. Hang on. Six, 3, 6, 740 times 0.0.
Isn't it supposed to be the run? Not the elevation?
Say that again.
Well, if we're
50
we're trying to find the increase in elevation.
Right, that's right.
So
This is
it should be run
yeah, it's 15
15 meters
That's right. It's 50
times
the 0.052. Yeah. So it's 15 meters times the 0.00. What is it? 0.2 zeros? 0.52 divided by 100. Yeah, 0.052. Sorry, that is correct. So that's 0.078 meters. Or if I times that by 100, I can get mils. That's 7.8 mils. So this number so yes, what we do is go 640 or shit. I keep on doing that. 636. 740, adding the rise 7.8, somewhere around there, I think. Uh, 636,818. How did I get 818? 636,818. That still doesn't make any sense to me.
Yeah, I'm
Dustin,
pretty lost.
where did you get the 636,818
I
from?
get lost now.
Yeah, I'm lost too. I got distracted.
Yep.
Dustin.
Yeah, lost.
Okay, so we got the 636,818 from the previous question. Oh,
Are we just restarting the question now?
Yeah, I didn't even do it. I just looked back at question O and took my answer and then minused it from what we got with
well, that is exactly correct. Right? That is correct. So if I go, let me just 636,740. We added that, so 15 times 0.0052. Okay, and times 1,078. There it is, plus 636,740. There is the number. So this should be 78 mils. And we add that together because this is the rise. The 78 mils is the rise, and we add it to the 636,740 to get 636,818. And we found out this invert here at 636,485. You minus them off, and it comes out to 1640 mils. There's your answer. Yes. Thank
Need
you,
to quiz this
Suzanne.
up for an extra couple seconds.
Yeah.
Oh,
Sorry, I got a little distracted there. Sometimes you need to keep, I need to keep focused on stuff. Just. Okay, we got that. Can I erase it now or you got it?
I'm good now.
Brad, we're gonna blame it on Marty. Marty is the one that called me, so yeah, let's blame it on him. I'm gonna get rid of that. And get rid of that. Wow, my computer is so weird this morning. I don't know why. Okay. Okay, let's go to the next question. We have, what is the difference in elevation along the north property line? What is the difference in elevation along the north property line? Do we go from there to there? What's the north property line?
Is it 420?
It is 420 mils. That is right, Dan Galili. Yes. Six,
460 now. Isn't it 460?
So if we do it from here to here, it is 460. Is this the north, along the north property line?
No.
Ooh. Okay. Actually, what they're asking for, let me just reiterate, isn't this the north property line? Everybody?
Yep.
Okay. This is the north property line right here. Okay, this is along the north property line, so we take the difference from there. And that difference is 420 mils. Okay. Now, what is the difference in elevation along the east property line? And now the east property line is from here to there. And what is the difference in elevation from that?
isn't that the west?
Is that the west? Oh, that is the west. Here's the east. This is east, west.
Never eat soggy wiener.
So got the news on there. So that is 0.46. That is correct. The difference between this elevation and this elevation is 460 mils. Okay, next question. We're almost done here, which is great. What is the largest elevation difference on the lot?
780 millimeters.
No, what is the largest? Like go from northwest to southeast? What is it?
Northeast and southwest.
So that'd be northeast to southwest. That's the manhole though. You don't want to go there. It's here, right? Here and here. There's the biggest difference between. Northeast to southwest is the biggest difference. Northeast to southwest corners is the biggest elevation difference. So what percentage of the lot is covered by the house? So we take the area of the lot and the area of the house, and we make one of them a part, the other one a whole, and then we can get a percentage. Put your answer in the chat. The house is the part and the lot is the whole. That is correct, Connor. So it's 18.7% is the answer. The next question says, let me just move this over a little bit. Come on. Wow, my computer is not working very well today, but that's just me. Okay, here we are. The next question says, if you have to put some dirt on there or 100 mils of sand under the building drain, how deep do you have to dig the ditch at the house? So you have your shovel. How deep do you have to dig to put 100 mils of sand under your pipe? How deep do you have to dig? Put your answer in the chat. Brett, close enough. That is correct, Dustin. Anybody else? Now, remember, everybody, this is the ground level here. We won't start digging. We start digging here and then we go down. So this distance from here to there is going to be 2850 minus 1050. So that's going to be 1,800 from here to the basement slab. And then we add 100. And then we add 200. And then we add 200. And then we add 100. And then we have 100 for the sand. $2.5 meters total. 2,500. Okay, so that is that question. The next. Let me just erase that. And my computer is so lagging. Okay, the next question is the main floor higher or lower than the highest point on the lot? That's all you have to say, higher or lower.
Higher.
It's higher. You bet it is. This is the highest point on the lot, right? 642,220. That's the highest point on the entire lot. So the main floor is the highest point. And you know what? For most houses, it usually is, because if you don't, I mean, you may have some water issues. Okay. So how much higher or lower is the grade at the side of the house where the building sewer exits at the southeast corner of the lot? Is it higher or lower? And how much? And by how much? So take your time, try to figure out that question. Okay, so how much higher or lower is the grade at the side of the house? Okay, the grade at the side of the house is right there, right? This is the grade level at the side of the house. Okay, and that's right here. So the grade level at the side of the house to the southeast corner of the lot. This is the southeast corner of the lot. So what we'll do is we'll take the finished floor, 642,2220, minus off this much to get to the grade, 1050. That gives me the elevation at grade at 641,170. Now we can minus off the elevation at the southeast corner of the lot, which is minus 641,330. And it gives us a negative number, so that means it's lower, and it's lower by 160 millimeters.
Sorry, where'd you get the 1050 from?
The 1050 is right here. That is from the geodetic elevation of the finished floor to the grade level of the ground right here. You see it there? Yeah. So this question is just, it's a little more difficult to understand because you really gotta visualize some of this stuff. Okay, the next question is how much higher or lower is the main floor than the highest point on the lot? So is it higher or lower? And then by how much? So there's our finished floor at 64220. It is the highest for sure, but by how much? So we got to find the other elevations. Which is the highest one here? 641,790. So 64220 minus 641,790. It is 430 millimeters higher. Yes. Thanks, Henry. Okay. Got a couple more questions to go through here. We're almost done. If this footing sits on undisturbed earth, so they're talking about right here, everybody can see, we're talking about the footing. This is the footing. Right there. If it sits on undisturbed earth, how deep would you have to dig for them where the building drain exits the building? So again, it's this distance. All right, it's this distance in here. So we take 2850 and I'm gonna minus off the 1050 from it so I can get the elevation. So it's 1800 and then we add 100 and then we add 200 equals 2100 millimeters. There it is. And the very last question is, what is the architectural elevation of the grade level where the building drain exits? So we want grade level. Anytime they say grade, that means ground. The grade level here. So we have 100 meters for the architectural right here, the top of the finished floor, and then we minus off 1.05 meters. That's the 1050 again to get 98.95 for the last question.